Hello and welcome to another episode of What in the World is Dyscalculia. This podcast is all about the math learning disorder, and I am your host, Dr. Honora Wall, and the podcast is presented by EduCalc Learning. You can learn more about dyscalculia, become a certified dyscalculia specialist, or get some courses as an educator, a parent, or a person, especially students with dyscalculia, at www.educalclearning.com. You can also visit the Dyscalculia Training and Research Institute at www.thedtri.org. And that is a great place. It's a 501c3, and there's a lot of free information about dyscalculia. It's always growing. We're doing some really interesting talks with a couple of different states about how their departments of ed might address dyscalculia awareness. And we've got our finishing touches being put on a free training course for educators about how to write a great IEP for students with dyscalculia. So we'll be sure to mention that when it is live and available for you, but should not be long. Today, I want to talk about something that is really a personal issue for me, something that one of the many soapboxes I tend to stand on when I'm talking about math education. And this one definitely impacts people with dyscalculia, but it's also part of a larger conversation. So what am I talking about? I'm talking about when we push too much higher level math content into elementary grades, and this just mismatch we have going on of math topics in different classes. And this has come up with a few of my students recently, so this might not be the first time I talk about it, but I'm going to try to stick to the first thing that is on my mind today. And that is having too many algebraic concepts pushed into elementary math curriculum. And I'm going to tell you why. I'm working right now with a homeschool student who has high functioning autism and dyscalculia and has been homeschooled. And now he is at the age to graduate high school, and we're finishing up his math. Unfortunately, I just recently started working with this student, so we do have a lot we're trying to put into a short amount of time. Thank goodness he's exceptionally bright, very fast processing speed, good working memory skills, and we're able to progress really quickly. But because I did not work with him earlier, we have a lot of foundational gaps that we're addressing, partly to make sure we're meeting high school graduation requirements, getting him ready for college admissions and placement tests, but also because he really wants to understand math. He wants to be good with numbers and numeracy. And our first few sessions were very productive and very successful. So now he really wants to go back and learn all that he can. So we were talking recently about simplifying fractions. This was a brand new concept for him, just with the homeschool program that he was going through, and with his dyscalculia. Of course, the family had a hard time finding good materials or curriculum to help. If you're having that problem today, you should go to educalclearning.com and see what we have available, and our expanding product line for homeschool families. But when I work with older students, they didn't have that, and that's the case with this particular student. So fractions are brand new. We've been working on multiplying and dividing fractions, not a problem. Adding and subtracting with like denominators, not a problem, doing great. And before we get into unlike denominators, which is probably the worst thing we ever do in all of math, we're pausing and talking about simplifying fractions. And we're using a multiplication list. We're talking about some divisibility rules to have an idea of how you might simplify a fraction. Hopefully, everyone is still listening. No one has turned off the podcast crying because of the traumatic memories of simplifying fractions. I had those as well, so I feel for you. But stick with me. I'm not going to make you simplify fractions in this podcast. But while I was working with this student and explaining how simplifying fractions work, and also how do you know whether or not you can simplify a fraction? How do you know what number to use? Where do you start? These are all frustrating questions for a lot of students. And to my advice to him, I said, I want you to try to think of this as kind of a game. Every question, you're going to look at the fraction and say, well, what do I have here? What do I think I might do? And try. Just give it a shot. If both numbers will divide by the same number, great. Use that. If they don't, well, you kind of hit a dead end. Back up. Try something else. If nothing works, hey, maybe it's already in simplest form. And you're just going to give it a shot. This is the essence of problem solving. You're going to try it, and you're going to see what happens. And this is truly, in a perfect world, the essence of math instruction, especially in the elementary. And I know none of us have this experience in the real world, which is why I'm so frustrated, and I want to talk about this. In a perfect world, in my opinion, plus $5 will get you a small coffee, but here it is. We really should be spending that elementary time playing with the multiplication list, playing with division, and playing with these fractions and decimals, and using that problem solving not as a trending key term that we throw around, but as something where we actually put students in a place of, hey, here's a problem. We got a lot of different things we could do. Let's check them out. Let's see which ones work. Let's see which ones don't. And over time, we're going to see if we see any patterns emerging, and we can talk about those. On the other hand, here's what usually happens in a typical elementary math experience. We have a lesson on multiplication. It's really fast. You got to memorize it. If not, too bad for you. Then we have a lesson on division. There's a lot of facts. You got to memorize them, and if you don't, that's just too bad for you. You should probably try harder. Here's some flashcards. Now we're going to roll right into fractions. Fractions are very complex, so hopefully you can keep up because I'm talking fast. I got to show you all these fractions. There's a lot to learn, a whole bunch of different rules. You wrote them down yesterday. I don't know why you don't remember them today. Oh, and now we're going to simplify. How do you know when to simplify? Well, you could memorize all the divisibility rules in the world, see if they apply. Better be using those basic facts that you memorized. And I can't believe you didn't get this done. You failed another test. What is wrong with you? Why aren't you trying harder? Guys, this does not reinforce problem solving skills. This is not the method to make students engaged in a math class. This is not the way to expand on our natural abilities as mathematicians, because we're all mathematicians until we go to school. The methods we're using are not getting us to our end goal. If they did, our math proficiency scores would be through the roof. They'd certainly be higher than they are today, which in most states is way down near the bottom of the barrel, especially for students with learning disabilities. So what we're doing with students is putting them in a system where we are really setting them up for failure. We have bizarre expectations of memory and how that works. And we have these worksheets, and we have these problems that don't make a lot of sense, and then we chastise children for being wrong rather than reinforcing, hey, I like the way you gave that a shot. That one didn't work. Let's back up and try something else. Because this idea that math problems are problems to be solved, issues to be explored, things that you try and you see what actually works, and then you know what to stick with. That is the real basis of algebraic thinking. When we're given problems with variables, when we have to solve equations, when we're talking about the zeros of a function, that is an exploration. And we need to start fostering that explanation and exploration and techniques of giving things a try and seeing how it works out. That scientific interpretation and crossover between math and science, making a hypothesis, doing an experiment, seeing what your results are. That is really something that I feel is missing in most math classrooms, especially at the elementary level. One of the reasons why it's missing is because we don't have time to do that. We cannot rest in the world of actual problem solving because we have to get to all of these other standards and topics, and we have to hit all of these different things that really can come up later. Of course, elementary students are capable of understanding that equations and problems have unknown elements that can be solved for. Sure, but there's a reason why we have pre-algebra, algebra 1 and algebra 2, because that's where those equations need to be. They don't need to be showing up in 5th grade. They don't need to be showing up as the equation with the apple for the missing add end and we have to solve it in 2nd and 3rd grade. Because when we do that, we ignore or rush through the numeracy, the exploration, the idea that you're not making a mistake in math, you're trying something else. And you're going to try things until they work. Aha! This is how this works. These are my right tools. Now I'm building out a toolbox for my future success. There's been a lot of talk for many, many, many years about American math education being that inch deep and mile wide. I don't know why we keep talking about it if we have no intention of fixing it, but that's a soapbox for another day. But it really does create a lot of long-term problems in mathematical thinking, and it definitely takes the joy out of math instruction and a math class. It also creates an identification piece where the student is either a good student who is good at math or they're a failure who doesn't get it. That's not what math is about. That's not what problem solving is. And then we get very surprised that students don't want to go into STEM fields, that they're not taking more challenging upper level math classes in high school and college. We don't know why they don't focus on careers that include STEM classes. I don't think we can really be surprised when the crop we grow is tied directly to the seeds we planted. So what does this mean for you? If you are an educator, if you are a policymaker, that would be great. Help change some of this policy. If you're a curriculum provider, change the way you're writing some of this curriculum. We don't have to keep following this track. We know it doesn't work. We can look at national math scores, state math scores, our district. We can look at our individual students, and we know we're doing something wrong. If you're a person with dyscalculia or any other learning challenge that's kept math success away from you, understand that quite a bit of it could be the system that you're in. So don't stop trying to get some more help for yourself. If you are an elementary teacher or interventionist or a paraeducator or a homeschool parent, please put in more gameplay, more explorative discussion, spend more time on really tough things like simplifying fractions. Use tools like a multiplication list. Don't just put up a chart of divisibility rules and expect that chart to make sense. Divisibility rules are very hard to understand. I should do a future podcast on that. But make it more of a discussion where you talk about, hey, I don't know how we're going to simplify this thing, or if we even can. Let's talk about it. Do fewer problems with more depth, not as a modified curriculum. I'm not talking about modification. The way we use modified in education has a very specific meaning, and students with dyscalculia do not need a modified curriculum. They're perfectly capable of doing grade level work, and that's what they should be doing all the time. But in the classroom, there should be a lot more discussion, a lot more play, a lot more exploration, trying things out, and then when we've reached mastery, we can add more homework. We can add more problems to a test. That's one thing I'm finding with the K-12 math courses I'm making for students with dyscalculia. We're getting great feedback from our beta groups of students, and the main thing they ask for is more work. They've asked for more work to do. because the minute they get it, they want to do more. So the way they get it is by us, as the leaders of the instruction, slowing it down in the beginning, looking at it as a game to play, a problem to solve, a discussion to have. And then our basic facts become the tools that allow us to win the game, solve the problem, complete the discussion. Quit trying to force algebra into literally everything. Algebra has its own place. I have no problem with algebra, but it has plenty of classes that should be focused on it. It does not need to be in geometry. Trig does not need to be in algebra, geometry, algebra 2, and not have its own class. Calculus does not need to be in everything under the sun. It should have its own class. And if we had better boundaries, I think we'd have more people being successful and interested in taking these different math classes. And these topics do not have any place in elementary math, because in elementary math, we're supposed to be infusing enrichment of numeracy, of basic facts from adding, subtracting, multiplying, dividing, understanding how to take things apart and put them back together in a mathematical sense. We're supposed to be fostering problem solving, which does not include failure. It includes exploration. When we get that piece handled, then we're going to see a lot more people interested and successful in higher level math when it is appropriate for them to take it. I think that we will also see a real increase in proficiency scores, and we will definitely see an increase in math achievement, especially for people with dyscalculia. They will truly be able to reach their full potential when we address the system they learn in. Well, thank you very much for listening to my rant about having better boundaries in elementary school math, protecting the numeracy aspects of elementary math, and encouraging a real problem solving and game taking approach to learning math so that we have a foundation for later. I'm Honora Wall, and I am happy to have had you with me on this podcast for What in the World is Dyscalculia? If you have any other questions, comments, or concerns, you can find me on TikTok, Instagram, LinkedIn. We have a teachers support group on Facebook, and you can email me, honora@educalclearning.com, honora@thedtri.org, or visit our websites for more information. We'll talk again soon.